Okay, so in this video we're going to discuss expanding and condensing logarithmic expressions. So the first thing that I want to talk about are the three rules. We have the product rule, the quotient rule, and the power rule. So the product rule says that if we have two logarithms that have the same base that are adding, those can be rewritten as a single logarithm of the product of the arguments. So it's going to have the same base. Notice they all have base A. So we went from the sum of two separate logarithms and their argument, xy, to a single logarithm of their product. Okay? The quotient rule says if we have two logarithms that have the same base and they're subtracting, that can be written as a single logarithm with the same base of the quotient. Notice it is the first term divided by the second term in the subtraction. So the same order that you subtract with the same order that the argument will divide. Okay? The last one is the power rule, and the power rule simply says that if our argument has an exponent, that we can bring that exponent down as a coefficient, as a multiplier. Okay? So the two things that we do is we expand and condense. So by definition, condense means to make smaller. So when we condense, that means, so this is going to be condense. That means we are looking for sums, differences, and multipliers, and we're going to turn them back into the product, the quotient, and the exponent. Okay, so condense means we're going to go from this expanded version back to a single logarithm. Okay? On the other hand, when we have expand, that means we're going to start with the single logarithm and we're going to apply as often of these rules as we can. Okay, so I'm going to start with one logarithm and I'm going to go to a statement that's a multiplication statement, a subtraction statement, or an addition statement. Okay, so condense goes from multiple logarithms for product and quotient to a single logarithm of a product and a quotient. And power rule goes from a multiplier back to an exponent. So when we expand, you're always going to start with a single logarithm. You're going to look for things that are multiplying, write them as addition. Look for things that are dividing in the argument, write it as subtraction. And look for things that are exponents and write them as a multiplier coefficient in the front. Okay? So let's look at our first example. So I want to expand the following problem. So I'm going to start with that single logarithm and I'm going to write it in as many logarithms as I possibly can, applying every rule that I possibly can. So the first thing I see here is that I have a quotient. So quotient, remember, means subtraction. So I'm going to write this as log base 6 of u. The same direction I divide is the same direction that I subtract minus v. So then I'm going to say, well, how do I know if I'm done? That is a very common question. Well, you are done expanding when you can no longer apply any rule. So the first thing I'm going to look for, do either of my arguments have multiplication? No. I have a u and I have a v. Do either of my arguments contain division? No. Do either of my arguments contain an exponent? No. Can I simplify? Is this 6 to a power? Does it have a power here like a 36 that it goes to? No. I'm completely done. That's the end of the problem. Okay? Number 2, so this is the one that kind of comes off the last unit that we did with radicals and rational exponents. None of our rules tell us what to do with a radical. However, we know that we can rewrite that radical as an exponent. Okay? So remember that it's the power of 1 over the root, which is 3. So I don't have no part of my argument is multiplying, no part of my argument is dividing. The only thing that I have is an exponent, so I'm going to bring that out front as a multiplier, and I'm done. Okay, number 3, same thing. There's no multiplication, no division, but I can apply the power rule. So I'm going to have 4 times log base 7 of 5. 7 to no power is 5, so I know I'm done. Same thing, number 4, bring that down as a multiplier. 6 times log base 4 of u has a variable as an argument. Absolutely no way that I can simplify that. Number 5, so I have a product, so that's product rule. Product rule says that I can take that and write that as the sum of two logarithms. So the sum of log of A plus the sum of log of B. Again, how do I know I'm done? No multiplication, no division, and no exponents left. Okay, number 6, very basic quotient rule. 6 over 7 is a quotient. So log base 5 of 6 minus log base 5 of 7. Again, 5 to no power is 6. 5 to no power, no whole number power is 7. No exponents, no division, no multiplication. Number 7, again, we have that radical, so we need to tend to it first. We have no rules for radicals, so we're going to write that as an exponent. So I have a power of 3 divided by a root of 2. So I have no multiplication, no division, but I do have a power. So I have 3 over 2 times log base 4 of x. So I have a variable, so nothing I can really do to simplify there. Okay, number 8. So the first thing, just like order of operations, you have to do parentheses first, so you can multiply 3 and 11. But I want to exercise our rules here. I want to practice those rules. So we're going to do power rule first. We're going to take care of that exponent. We're going to do 6 times log base 6 of 3 times 11. So I'm not done, and I know I'm not done because my argument still contains a product. So I'm going to do 6 times log base 6 of 3 plus log base 6 of 11. Now you can distribute, you cannot distribute. It doesn't make it any simpler in this problem, but we can go ahead and distribute that 6 to each thing. So 6 log base 6 of 3 plus 6 log base 6 of 11. Number 9. So we have a product. So we have a power, but I can't deal with that power first. Notice that there's a very big difference in that 3 being there and the 3 being there. The 3 there says that everything in that parentheses is being raised to the 3rd power. The 3 being where it is says only the b is raised to the 3rd power. So I can't really do power rule first, because if I bring a 3 out front, I'm saying just like in this previous problem where the 6 is going to the 3 and the 11, so it has a 6 and it has a 6. This 3 is not going to the a and the b. So I'm going to do product rule first. So I have log base 6 of a plus log base 6 of b cubed. So then my a has nothing left, no product, no quotient, no power. This has no product, no quotient, but it does still have a power. So we're going to do log base 6 of a plus 3 log base 6 of b. And that's going to be my final answer. Now typically we don't see products written this way. Normally we would just see A, B, C, and that's product rule all the way across. All 3 of those things are a product, so we can break them all apart with addition. So log base 4 of A plus log base 4 of B plus log base 4 of C. Again, none of my arguments now contain a product or a quotient, and none of them have exponents, so I know I'm done. Number 11, again, we could apply some math rules to this, but we want to practice those logarithmic rules. So again, notice that the 3 is only to the 11, not the 10 and the 11. So we're going to do product rule first. So I have log base 5 of 10 plus log base 5 of 11 to the 3rd. So the 10, that first logarithm, 10 is not a product, it's not a quotient, it doesn't have a power, so it's as simple as it can go. 5 to no power is 10. Don't get divisibility rules confused with 5, with these exponential rules that we're using with logarithms. 10 is divisible by 5, but 5 to no power is 10. So 5 to the first is 1, and 5 squared is 25. So we bypass 10 in whole numbers. So the last thing we have to do is to deal with this power. So I'm going to have log base 5 of 10 plus 3 times log base 5 of 11. So we have the same scenario as we did in number 11. It's just variables. Sometimes it's a little easier to see it with variables. So notice this time the 6 is on the outside of the parentheses, which means it goes to the x and the y. So I'm going to have 6 times log base 7 of the product xy. So I look at my argument. It still has a product in it, which means I haven't expanded completely. So I have log base 7 of x plus log base 7 of y. So you can distribute that 6 log base 7x plus 6 log base 7y. Now it doesn't make it any simpler, So either one is an acceptable answer. Number 7, again, we have that same setup. We have some repeated problems. I'm sorry for that. So we have 12. Let's skip to 13. Here we go. Okay, so again, we have several things happening here. We have more than one power rule. We have product rule. So again, that 3 is to everything in the argument, so I'm going to bring it out front. So 3 times log base 2 of x cubed y. So I still have product, so I'm definitely not done. So 3 times log base 2 of x cubed plus log base 2 of y. So I still have a power. No products, no quotients, but I still have a power. So 3 times log base 2, 3 times 3 log base 2 of x plus log base 2 of y. Again, you can distribute or not distribute. It's, as far as simplification, it's definitely an equivalent, and it doesn't make it any more or less simple to distribute. Okay. Number 14. Again, we have a product, and again, we have that radical that we need to write as an exponential. So I'm going to do that first. Log base 3, z to the 4th, x to the 1/2, so power of 1 over root, understood to be 2. So I'm going to deal with the product rule first because I can't pull either of those powers out because they only go to each individual. So I'm going to do log base 3 of z to the 4th plus log base 3 of x to the 1/2. Now, I don't have a product or a quotient, but I do have a power. So I'm going to do 4 log base 3 of z plus 1/2 log base 3 of x. Okay? So number 15, several things happening, but the most important thing to take care of first is that square root. So I have z x y to the 1/2. So remember, this is power over root, so I'm going to write that square root as a power of 1/2. So the first thing is I'm going to break apart this product between z and xy because these things are grouped together by that power. So I'm going to do log base 9 of z plus log base 9 of xy to the 1/2. So this first logarithm doesn't contain a power, quotient, or product, so it's as simple as it goes. But this one still has a power that I need to take care of and a product. So we're going to take care of that power first. So I have log base 9 of z plus 1/2 log base 9 of the product xy. So I still need to break apart that product. So I have log base 9 of z plus 1/2 log base 9 of x plus log base 9 of y. Okay. Number 16. So I'm going to do power rule first. I have to deal with those exponents first. That 5 is going to everything in those parentheses. So I'm going to bring it out front. 5 log base 8 of a over b to the 4th. So I still have a quotient, so I need to fix that. So I have log base 8 of a minus log base 8 of b to the 4th. So just like you would say a divided by b to the 4th, it would be a minus b to the 4th with the logarithm. Okay, so no products, no quotients, but I do still have a power to take care of. So I have 5 log base 8 of a minus log base 8 for log base 8 of b. Okay, again, you can distribute or not distribute. You're going to get the same answer. Along with that, I'd like to point out that we could have written this as a to the 5th, b to the 20th. And if you notice, if you distribute, you would get that same answer as using quotient and then power. This is just, again, an exercise in using all the laws. Okay, so mathematically, they're the same answer. Okay, number 17. So again, I have power and product. So I have 2 log base 8 of x cubed y. So I've taken care of the power, so I need to take care of this product. So I have 2 log base 8 of x cubed plus log base 8 of y. Please notice the addition of the parentheses from this step, from the first step to the second step. It's very important because that 2 goes to everything, just like the 2 goes to everything here. So just be super cautious with your notation. Again, the last thing that I need to take care of is that power. So I have 2 times 3 log base 8 of x plus log base 8 of y. Similar here, except quotient rule, so I'm going to use the 2 out front. 2 log base 2 of a over b to the 4th. So I have 2 times log base 2 of a minus log base 2 of b to the 4th. So I have 2 times log base 2 of a minus 4 log base 2 of b. Okay, so now we're going to move on to the condense. So remember that to condense, we're going backwards from what we've been doing. So just as a reminder, I want to say, so condense, remember, we're going to go from something that is in the form on the right-hand side of the equal sign to that single logarithm in the form. So even though the power rule is still a single logarithm, notice for the condensed version, it's back as an exponent. For the expanded version, it's a multiplier. Okay, so keep in mind those rules as we move through which direction we're moving for condense and expand. Okay, so we're going to start doing some condense. So the first thing is when I know I have that multiplier, I know that it used to be an exponent. So I'm going to have log base 5 of 10 to the 6. Now it does me 0 good to raise that to the 6th power. This is just practical practice, okay? Number 20. Now this might be a little confusing. So what do I do with a divide by 3? So you have to remember that we could write that as a multiply by 1/3, which means that now as a multiplier, it used to be an exponent. So I have log of x to the 1/3, and you can even write that as the cube root of x. Okay, now as a reminder, I'd like to take it a second to remember that this is a common base. So this is a base 10. Don't forget, if you don't see a base, it's an understood 10. Okay, so number 21. So I have a difference, and I know that I can write a difference as a single logarithm where the argument is a quotient. So I have log base 7 of u divided by v. U divided by v. In the same order you subtract, the same order you divide. The same here. So subtraction can be written as a single logarithm, x divided by y. Number 23. So product rule says that if you have 2 logarithms that are adding, same base, then I can write them as their product. So 7 times 2. And of course we know that we can simplify that to 14. Now 4 to no power is 14, so I know that I'm done. 4 to no whole power, whole number power is 14. So again, we have multiplication or addition, which tells me that I can use the product rule and write this as a single logarithm of their products, which would just be a times b. Number 25. So just like every other math sentence that you've ever done, you read from left to right and you do PEMDAS. So I'm going to have to deal with this power first because the 5 only goes to the 11 and not the 8. So I'm going to write this as log base 7, 11 to the 5th minus log base 7 of 8. Now I know that subtracting 2 logarithms can be written as a single logarithm as the quotient of their argument. So 11 to the 5th over 8. Same process with number 26. I need to move this 2 back up as an exponent. So I have log base 3 of x plus log base 3 of y squared. And again, product rule says that I can write the sum of 2 logarithms as the product of their argument. So log base 3 of x y squared. So again, this is just a simple product rule. We want to bring that back up as an exponent. So log base 8 of x squared and log base 9 of a squared. Okay, so all of these are additions. So these are all product rule, and we can read from left to right. So just like you would every other math sentence, left to right, you do what comes first when you're talking about addition and subtraction. So I'm going to have log, so these two, I'm going to do those first, be log of uv plus log of w. So this is still product rule, so I'm still going to multiply, so I have uv w. That would be my final answer. The same here, left to right, there's no other grouping symbol, so I'm going to do it in order from left to right. So I have log base 2 of 84 plus log base 2 of 5. Still product rule, so remember this is 12 times 7. So still product rule, I have log base 2 of 84 times 5. So I have log base 2 of 420. Now, if you're not sure if 420 happens to be a power of 2, you can absolutely plug that in your calculator and see. So we have 2 to the 7th is 128, 2 to the 8th is 256, 2 to the 9th is 512. So I pass it between 2 to the 8th as 256 and 2 to the 9th as 512. It just passes 420. So no value, no whole number value can I use to raise 2 to that power and get 420. So I'm completely simplified at that point. Okay. So here, these require a little more thought. So I notice these are all dividing by 2. So like the earlier problem, I can pull that out as a 1/2. Okay, so once I do that, I notice that I have a GCF of 1/2. So every one of these things would be under a radical or raised to the 1/2 power. So I'm going to pull that out just to make putting this together back together a little bit easier. So I have log base 5 of z. So again, from left to right, I'm going to use product rule. So these are all products, so it's going to be x times y times z. So I have log base 5 of x times y times z. So power rule says that I'm going to bring this back up. So I have log base 5 of x, y, z to the 1/2. And if you so desired, you could write that back as a radical. Either one is an acceptable answer. 32. So before I can do quotient rule, I need to take care of those exponents. So I have log base 6 of a to the 3rd. So I'm going to bring it back up, minus log base 6 of b to the 6th. So this is going to be the quotient of log base 6 of a to the 3rd over b6. So remember, same order, left to right, top to bottom. So again, this is very similar to the next to last one that we just did. So I'm going to take that 1/3. I'm going to go ahead and take it out. Log base 7 of x plus log base 7 of y plus log base 7 of z. And again, this is product rule all the way across, so I can multiply all of these things. So it's going to be 1/3 log base 7 x, y, z. So that 1/3 used to be an exponent to these three. So log base 7 x, y, z to the 1/3. And again, you could write that as a radical, the cube root of x, y, z. Okay. So again, we have these powers that we want to bring up. So I have log base 4 of a to the 3rd minus log base 4 of b to the 3rd. So I can write these two as the quotient of log base 4, a to the 3rd, b to the 3rd. Be careful that you don't see things that are common and start crossing out or trying to simplify or take the cube root. This is not an equation that we're trying to solve. It's an expression. So just be super cautious, okay? Number 35, the same thing. So I'm going to bring my 3 up and my 15 up. So I have log base 3 of u to the 3rd plus log base 3 of v to the 15th. So this says product rule. So because they're adding, I can write this as a single logarithm as the product of their arguments. Again, same exact scenario. Log base 5 of u to the 3rd plus log base 5 of v to the 12th. Again, product rule says that I can write this as a single logarithm of the products of their arguments. Okay, last two. Okay, so again, I want to use power rule first. Bring this up. So I have log of 5 squared plus log of 16 to the 1/2. So log of 5 squared is 25. 16 to the 1/2 is 4. So this is product rule, so I'm going to multiply. 25 times 4 is 100. So then I have to ask myself, am I done? So you have to remember again here that the base is 10. So is 10 to any whole number power going to equal 100? And the answer is yes. 10 squared is 100. So my answer is 2. Number 38. Again, I'm going to bring that up. My power back up as my multiplier back up as a power. So I have log of 2x quantity squared. Now, if you're going to mess up, that's going to be it, because you're going to square that x and not square that coefficient. So be super, super cautious. The same in the next one. So I have log of quantity 4y to the 1/2 minus log of quantity 2x cubed. Okay, so before I started putting this together, I would likely try and simplify. So I have log of 4x squared plus log of 4y to the 1/2 minus log 2 cubed is 8x cubed. Okay, so a math sentence we read left to right, so we're going to do it in order from left to right. So the first thing I'm going to do is product rule. So I have log of 4x squared times the square root of 4y. There's nothing I can do with those two things. They are not, there's not a way for me to multiply them. This is trapped under a radical, so there's nothing for me to do here. So I'm going to move forward. I can simplify this radical, and I'll get to that in just a second. Log of 8x cubed. So now I'm going to write this as a quotient. So log 4x squared, square root of 4y, all over 8x cubed. So obviously here now I can do some simplification. So this is going to give me log. So 4 over 8 is 1/2. X squared over x cubed is x, and I'm left with the square root of 4y. And we know that 4 is a perfect square, so I'm going to have log of 2 square root of y over 2x, and those 2's will go away, and that's going to give me a final answer of log square root of y over x. Okay, so it's very important that you remember your exponential laws. You have to know those. You have to know your logarithmic rules, and you have to know how to convert a radical to an exponential and back and forth. And obviously, simplifying radicals could appear, so you need to be super, super cautious.